Hi, today we are going to perform text classification on IMDb movie reviews using BERT model. So here is my collab notebook. So the first step we are going to perform is that we are going to download the IMDb dataset, and next we are going to load the BERT model from the TensorFlow app, and we are going to build our own model by combining BERT with a classifier, and we are going to train our own model and fine tune it, and finally we are going to save the model for using for next classification of the sentences. So first of all, we will run the shell to install the TensorFlow text file. Done. The next we will install TensorFlow models official, and we are going to import the required packages of TensorFlow Hub and TensorFlow text. And official from my official NLP, we are going to use optimization, which is Adam W optimizer. And now we are taking the Stanford's IMDb dataset, which which dataset contains the reviews as positive and negative based on the review given. So as I don't have the data, I'm giving the URL and it will download the dataset folder. So we can find on the left side the dataset tar file and the folders. Yeah, here we got the IMDb, and in this if we see the train and test data is out there. Now we are using TensorFlow keras preprocessing to make the training data, and in the train data we are taking in the IMDb we are taking the training part as 80% and remaining 20% as validation part. So out of 25,000 files which belong to the two classes, we are taking 20,000 files for training and remaining 5,000 for validation. And we are so looking the top some three reviews and the labels. Here first review is a pandemic is horror movie spoof that comes from more stupid than funny. It is a negative review. And the last one, great documentary about the lives of NY firefighters. There, so the text is mentioned about the positive tag. We are looking, and now we are using the small bet model. We are using the bet model and the preprocessor as same the model. And first we are loading the preprocessed bet model using keras layers layer, and then small text we are taking. This is such an amazing movie. On this text, how the bet preprocessed model will give the results. We are going to print keys, shapes, word IDs, input mask, and type IDs. So these are the results with respect to, and the shape it will take the maximum length as 128 and not more than that. And keys, input word IDs, input mask, input type IDs it's going, and for each word it is assigning some IDs to it and mask to that, and I type IDs. What was the type it was? And we will load the BERT model now. And we will see that preprocessed text how the BERT results will look on that. And we will see the pooled outputs and sequent output values. So here are the pooled output values and sequence output values. Next we are building the classifier model. Yeah. And we are Now let's check the model runs and how the output of the model pre-processing model looks like. Tensor 0.68 and shape 1 comma 1. So, and we will see the model structure of the classifier model, BERT classifier model. So this is the structure, the input layer which the text was given, and the pre-processing keras layer it is using, and the text was converting to using BERT encoders and using some dropouts in order to control the overfit, and we are using dense classifier, and we are using the binary cross entropy as a loss function since we have only two classes, and the metrics which we are taking is binary accuracy, and we are taking the 5 epochs, and we are initial learning rate 3 e power minus 5, and we are creating optimizers, and now we are compiling the classifier model by using above optimizer and loss and matrix functions. Now we will perform this training model and we will fit the model. So we here there are 5 epochs. In each step we are having 625 steps. So it will perform those and it will result the loss of 0.81 and binary accuracy and the validation accuracy. This is the training accuracy, and next it will comes the validation accuracy. So we will wait for the 5 epochs to go. So we got validation. First epoch we got validation loss of 0.51 and training loss 0.71, and training accuracy 54% and validation accuracy is 72%. For the second epoch, the loss has reduced from 71% to 51, and training accuracy has increased, and validation accuracy also increased. and from second epoch to third epoch the loss was decreasing and the training accuracy was increasing, validation loss also decreasing, and validation binary accuracy also increasing. And we are going to perform the last epoch, fifth epoch. So in the fifth epoch we got the training loss 40%, it has decreased from 70 to 40, and the training accuracy from 54 to 81%, and validation loss from 51 to 43, it reduced good, and by validation accuracy from 72% to 78. So we are performing how evaluation on the test data. So we are printing the loss and the accuracy, test loss and test accuracy. So test loss is 40% and 78% is the test accuracy, which is similar to the validation binary accuracy. And we will plot the accuracy and loss over the time. So the first plot is for loss, training and validation loss. Here the red line is for the training loss and the blue is for validation loss. Same with the second, training and validation accuracy for how many epochs. So four, for 4, for 5, the plot looks like this from 1 to 5 epochs. And for future reference, we can save our model. We can give a name, model path, and we will save the results as our model. Here the model was loaded, and we are going to use the reloaded model. We are going to load this model, and we are taking some small examples. For example, this is such a amazing movie. The movie was great. The movie was okay. It's like these examples, and we are going to perform the low reloaded results and the original results. So from the saved model results, the input for giving which we are given. This is an amazing move. The scores are displayed as similar both in the memory and the saved model. So like this we can save the model. Thank you.